Hello guys, it's time for another OptiNews. Although I'm not sure if I have many news. I was hoping to do more on 3DO, for example, but unfortunately I don't have much on 3DO. But there was some plans I had, and I guess my biggest plan is to try to continue with Bizarro Underground. Now I have for 2024 some stuff. Not everything here are stuff that I will work. Sometimes I work in those folders, it's just a mess here. And I open this and I work something here. Sometimes if I say, I want to work more with it, I just copy it on 2024. Sometimes I open new folders, like I'm starting a new project for that, and there's a lot of junk in all the years that I never, they are empty frameworks that I never work. So I'm gonna remember. Unfortunately, Bizarro Underground. This is the thing that I should finish this year. And maybe early enough if possible. I did some. Nah, just. I added the bench functions. Last year, December, I was trying to write assembly version of the map cell. There was a little improvement because there is overhead in other places, but it's welcome because. But yeah, I haven't done anything. But the thing that I started, this is a new thing. Unfortunately, this compiles but doesn't run yet. It crashes. But this is. It compiles, ship it. Oh, I made it a C project. There was a main CPP and I changed it to main C for some reason. Because the thing is, I did a crude port, but not completed. It doesn't run yet. Half port. So there is an effort. And when was that? I started an effort. Back on February, okay. Before I got involved in something. To start porting, this is the 3DO, the whole 3DO. That's a lot of code. On a PCSDL, yeah, nothing happens. It might even crash or freeze. But I just ported everything and I have to replace. It opens an SDL window and everything compiles fine. And I might have replaced some 3DO functions. The matrix multiplications on the 3DO with my own. The map cell. I'm doing some map cell from a quad. I have replaced some stuff. I have the CCB struct. I have to do load cell to do unload, especially draw cells. Now I'm not going to emulate the whole cell. I'm just going to emulate the basic texture. And why am I doing this port? There might be there might be few ones that remain. I have an SDL window, I can do software. I was doing this port because I realized first. So I ran a simulation of the original on the PC for faster debugging because I might have some issues now. I want when you finish a level to clean up everything. I was trying previously when you finish a level to clean up everything and init stuff, and it was crashing on the 3DO because something was still not init or stayed in memory. So it's better to be much easier to debug and put some breakpoint and see what happens easily. That's one thing. Because I want to work with this one and try to finish it, but it might be better to have a port. And there's another reason. I want to make an option when I run the PC port where you will float, you will move like it's, and even in an empty map, like it's Minecraft, so that I can place blocks and remove blocks, so that I use it as a level editor. I will remove place block, I will start digging in full solid, digging corridors and whatnot, and then press Ctrl S or whatever and save it. So I want to, on the PC version, I want to test it, but then with another version of this project, also use it as a level editor. And this will also, I will level offload. There is some code here that is recalculating lights and it takes time to load. So I'm going to offload that too. Now the visibility was happening on PC before with some other. I took parts of the code and copied it in another place. So I'm going to be completely running the same code here with some emulation of the 3DO rendering and other functions. Only the necessary, not a complete emulation. And not a complete emulation of the cell. So that I can easily test and also use it as a level editor. Because previously I was using some functions that I write by hand that would dig a solid 32 by 32 by 32, whatever, how big it was. I don't remember. It would dig corridors, and I would do it in my mind visually, and it goes awkward. And this will allow me to even make much better levels and more stuff. This is great. This is fundamental. I could stop. I could stop developing this one and try to finish the port, because then through this I would be able to start actually working on the game more efficiently. And I don't have much. I have Bugo. Those are empty projects. Bugo fixed. I had the interest to, in modern PC, to start making either a ray tracing, and I wanted to try to see if I can make a fixed point ray tracing that I could backwards port in older platform. I'm curious about something. And that was just a regular software render engine on a modern PC. And those two, especially this, I'm curious. I haven't done. I would like to see what the modern PC can, if I fight with it again. How far you can push the software render. Because I see people trying software renderers, even basic ones, and on the PC, and some of the modern ones are not very, very fast as I would think. And for some of that stuff, maybe another, I might try some simmed code. That's another thing. Anyway, engine CPC, yeah, that's for the CPC. I wanted to start a new 3D engine again. I copied the experiments because maybe I was working on something. Now I'm not showing anything. Yeah, I did a bit of optimization on the software 16-bit rendering using a different. Okay, maybe that's not it, but tiny ones. That was before Christmas and after that I was. I mean, that's kind of useless on the 3DO. That software rendering on the 3DO I was as an experiment. I had some idea on December about rewriting my triangle rasterizer in a different way, but that's not very useful for the actual 3D projects I want to do. That was experimenting. I just wanted to experiment. Now, why did I copy this here? Because I recently tried something. I might have tried to also to replace the faster map cell. Did I have improvement on the sneak? I think there were tiny improvements. You know, these are the things that you are not motivated to work on the primary projects, and you have some idea for some experiment that evening that is more exciting or something. Now, the Sam Coupe, the main things I'm working, I guess after coding some Z80 assembly for a long time, I started getting interested in. I missed the Z80 assembly. Okay, maybe. I had an old project here. For some reason, I use code blocks for this project. I use those weird IDs that nobody uses. Why is it popping many times? This one takes so long to load. I don't understand it. So this is a system I also did for CPC. I have showed that before, where if you use the debug mode, I am in some of the stuff that I don't include on the Sam Coupe or CPC, PC underscore core Sam, PC underscore. So here I emulate maybe one of the video modes of the Sam Coupe. Sam palette, Sam video RAM. I've shown you. I did a similar thing on CPC. So I created a system where I can rapidly develop without having to build an image for Sam Coupe, for Sam Coupe or for Amstrad CPC. I think I started something for Spectrum too. And but I have to remember to use get pointer address, and if the project is not, if you put debug it's running here, I'm going to call some function that emulates the different Sam Coupe memory, the memory banks that are flipped. But if it's a real sum, and I say I want the address 4000, hexadecimal 4000, it's gonna go there, and some other functions will flip-flop, like PC. Is it here? So here, if I run it, I get this nice plasma. But this is an emulation of what you would see. Now it's a bit blocky, and I'll show you. And if I build it, so I switch it, and when you switch it, it uses SDCC instead of GCC, and it created that one. I made a nice system for rapid development, and here I just have to boot it, and there you have it. Look how smooth this plasma is, and how big. Now, it's not that big, it's really 64 by 64, but again, I will show you something amazing. So that's the Sam Coupe. Sam Coupe. So it's this one. I mean, it has a Z80 at 6 MHz. It's a bit faster than the CPC. But it has a nice linear video RAM. This is in 16 colors though. 1 byte is 2 pixels. But because I'm lazy and I'm not mapping pixel, I just get a value from 0 to 255 from the pixel and just split it, just write it. And so sometimes you get, it's not pixel after pixel. In some places, you will see it's not just gap, there are 2 pixels different. So it kinda matches it, but it's a bit dirty. It's like to make it faster, I was like, normally you would have to get a byte, have a mapping table to get the left pixel on the byte and then the right pixel, or them together, right and back. But I was surprised this one works quite well here. And this is a 64. It's really 128 by 120 and vertically I skip one line, so it kinda, so this should be that small. a quarter of this, really. But it works, and this is 50 frames per second. And actually, let's see. And here is the most amazing thing. I was trying various things. I have some unroll stuff. I have unroll C, unroll assembly. And I don't know if this will. I'm doing that if it's debugged so that I can see it, it's gonna ring the regular algorithm. Because I'm not emulating the assembly on the PC side, obviously. And I'm running this one, and I have various versions. I have command. Oh, I run this one now. I haven't separated it. So let me show you something. I should have made 3 functions. Okay, let's. And I'm emulating the unrolled one. So, oh, it's even 80. But the assembly, is it 80? Oh boy, it's 64 by 80. Not even 64 by 64. It's even bigger. And it's 50 frames. Wow. It's barely, if you increase it. Actually, no, the assembly one, you will see. Okay. Plain. Let's see what we can salvage. I see some unrolling here. I'm gonna show you how. I will even have the plain one so that we can read it. Because I wanna show you my surprise, because normally I would say, okay, if you write something in C on 8 bits and it's not just let's move 50 sprite, but it's calculate things for 4096 pixel. And let's make it 64 first. I will even make this one. Is it all that it does? At the end you have to go back. And here I'm not increasing RAM because it's the last one and I know I have unrolled the horizontal. But here it's gonna be. Now the video RAM of Sam Coupe is great. It's more linear compared to other 8 bits. So you go 1, 2, 3, 4. Those are the. Okay, it has the resolution here is 256 by 192. And it's 4 bpp, 16 colors. So it's 128 bytes per line. Not linear linear congruential. What? So, but here, so if you just write bytes, but of course 1 byte 2 pixels, but pixel format is normal, like left, 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 right, right, right. Those are the bits. And also normal, like you know, 1, 2, 4, 8. So if you go color 15, it's gonna be 1, 1, 1, 1, and so on. So it's very, very normal. Because on the Amstrad CPC, it's hell. It doesn't make sense. On both the Amstrad CPC and the here, if you go 127, 128, the very next line will be 129, blah blah blah, 255, and now this is 256. So in assembly, I can okay, I get the L. I'm 256 byte aligned. Okay, it's also aligned, so we can get the L, the low byte, subtract 63, put it back, and then increase it to go where though? To go 2 lines below. So it's scan line after scan line. It's not every scan line. Else I would have to do LDD, no, maybe I could have done it in easier ways. Or do it, and if there is a carry, increase H2, else not, or no, yeah, okay, I could have done and now if there is a carry, is it a carry? Is there a carry? I'm not sure. Add C H, 0 or something like. Oh, I don't know if you can do H, 0. You cannot. Ah, damn. Anyway, I could have done. Yeah, it doesn't matter. It was easier to say inc H and go line 0, line 2, line 4. So I'm skipping lines. But even that's much easier than CPC, where it's plus 80 on CPC, plus 80 bytes, next 8 lines, then come back plus 2 for second line and so on. Anyway, so it's much easier. So why I wanted to say that? Because this is linear, and that's why. But also, I'm showing you how much good the Sam Coupe is for pixel effect. How much nicer to program for such effects. If you don't care about hardware tricks and CRTC, and you just want the playground for Z80, and it's also better than the Spectrum with those new video modes, because no tile restrictions, color restrictions, 16 colors from a really good palette. You have a pixel that is like mode 1, but if you have the blocky mode 0 pixel, at least you write a byte for that. You don't have to. It's not the left byte and the right byte together. The left bits and the right bits mixed. Just to even get the blocky. If you are lazy to get the good pixel, or you want to do things faster. Anyway, so that's why I'm subtracting 64 to go back, as I was increasing that to go back, and then go down 2 lines though. And see how simple this algorithm. Nowadays I like to do that. I used to be of the other type. So this is as simple as it gets. But it has to read from a table. These are cast to unsigned char, so we know that the compiler is not doing weird things with 16 bits. And the outer loop, okay, it's like that, the inner loop. I don't know if I could get, okay, yeah, I could maybe do a do while. That could, we will try that. So this is the sign 2 with y coordinate. We calculate as, and the inner, it's as simple as it gets. And normally other kinds of effects are going to be much more complex. What did it do now? Yeah. Why can I not see it? Error. Oh, did I miss? Oh, yeah, I missed it. Anyway, I took so much time with that, so maybe I should accelerate. And also, let's see that this works. Come on. Okay, this works, but now we are gonna do something. We were using the assembly version here, but I want to compare with the original C version. So when I did the original build it, C version. Now, you might see that the debug mode is fast, but that's because I don't emulate the Z8. But now I'm gonna run the original C version without unrolling, without tricks. And that's how slow. This is how slow. This is how different it runs. Unfortunately, I don't have a frame counter here because I just realized I was curious right now. How fast is that? 5 frames. So, okay, this is where I said, oh my god, you can never do something in C that in 8 bits, 8-bit computer. You can never do something that manipulates many pixels for such a thing. You can only move 50 sprites, move the position of 10 sprites, 50. Maybe do some 3D stars or 2D stars, 100 2D stars, and barely get it. Forget about it. And indeed, this is the simplest. A lot of demo effects are much more complex than that. Okay. So I never thought it was possible, but I'm going to do something now because I thought it now. This is gonna change the rendering a bit, but it doesn't matter because we are gonna get a similar result. Because this is usually a good optimization for Z80. I'm gonna see. I'm running the debug to see that okay, it works. We didn't broke it. You know it works if you do a mistake like this. Bang! Whoa! And it emulates the video RAM. I'm passing video RAM. That is the actual address of the Sam Coupe, but through it's running through some other function that depending on the banks switched, it will give you a mapping. So it's so cool. It's so cool for. So now I did some. It's so cool and it took me time to build. I have a similar system on CPC and I started one on ZX Spectrum, but there are a lot of things that don't emulate yet. Okay, I can't say the difference because I need to add a frame counter. But I think it's fine to have the do while. But anyway, then I made the unrolling. That's the other thing. Should we see that too? That's why. I could do it. Okay, I'm not gonna do it. I'm not gonna do it. But even the unrolling wasn't. It might have been a bit faster. And I haven't seen the code that it produced, but at some point I said, you know what? I did that one. So what I realized, when I started printing sine 2 of 0, I started printing that, you know. So I started saying printf, bara and yeah, for independent, you know, yeah. When I started printing these values out of curiosity, I realized that they were very close because it's a sine and it is even a short sine. If it's a long sine, so it was going like 0, 0, 1, 1, 2, 3, 4, 6, 7, 9, 10, 12, maybe faster, you know, and so on. And I realized, whoa, okay, first I did it like this. I unrolled it like this, those numbers. Then I realized, whoa, if we keep this YP intact, and then I increase, and there are places, I don't know, 0 plus YP, 0 plus YP, 0 plus YP, 1 plus 1, 1, 2, 3. There are places where the sine curves go slower and it's almost straight, where at those places there is no. And also this, if the compiler does a good job, which it did in this case, that's the amazing thing. Maybe, I hope I have the output. If it did a good place, and it knows to keep that in a 8-bit register, and just increase it and write it, increase it, and maybe this is on HL, on the 16-bit register. Write on HL, increase HL, LDHL, A, which is what I have here. But I have something extra that the compiler, 2 things extra the compiler couldn't do. But it still did a really. So there are cases where if you write some crazy weird and usually unroll code in compiler, that's not always the case because it's unpredictable. I'm on release. So if I forget about this plane and use this one, and remember how SC software render effect for 4096 pixel running say. Remember, like there is no way. But if you do that and it does some kind of optimal code, you would be surprised as I was surprised that a pure C 64 by 64 pixel on such an old 8-bit that even in assembly you would struggle initially to make it smooth. Pure C. Oh, interesting. Huh. No, it is fast. Did I compile it? Which version is that? There is something interesting. Okay, it is faster if it's that. There is something. I could get, in this version, I could get 50 frames per second. This seems slower now. Hold on a minute. Am I running this one? Am I running the plane? Are there, what is the... Now, imagine if the compiler now, because of changes, decided to generate slightly different code. But still, you get something that is not bad for pure C. I would get the result of that. Okay. I would get the result of assembly. The difference is that as in assembly, I could go about 90, 91, 92 lines. I would be just at 50 frames per second. If I go over, I would be more than 1 VBL. So the assembly code was 30% faster than the very good generated C code. But with 64, horizontal is 64 and vertical is also 64. These are 64 unrolls and then... Did I change? Maybe, okay, I will see. Maybe recently I updated my SDCC version. Okay, that's the assembly version. I swear to God, this is how the C version with 64 went. What are the flags? I mean, there are no optimization. Okay, that's interesting. Which means if you have a lucky one with C, I've said that before, you don't know. Which is the original? It's that one. Or that one. Why there are 4? Ah, this has to go. Whatever. You know, I'm writing my own assembly and then I'm converting. Is this the original output? There should be. Two of them, huh? Which is the one? Isn't that the maximum? Why I don't see any code that is like that? I have a special mechanism. Maybe it goes on the ANSM line. Find me an example. Anyway, it does. Oh, no. There it is, for example. This is the thing where I put bracket and I put things nearby that you cannot do. And that's what my tools do. I like to write like this for reasons. But anyway, so this is the original, then it's converted to ASM liner. Why there are 3 conversions? Anyway, plasma. Did it unroll it? Maybe. Render. Forget about render effects plane, but see, it does a lot of things. It uses IX a lot, which is very slow on Z80. Yeah, this is what these compilers do. They are not going to put the effort like a regular programmer. So yeah, everything is on stack, but the variables, but there is no effort to use totally the register in a tight loop. But there goes it. The unroll code. Is it that one? I've seen this spill per register. My God, it does worse work, man. It does worse work. Something changed. It uses the IX for that. This is the unrolled version. Ah, could it be? Oh, no. That's the one I made. Ink. That's why it's slower. Okay, you know what? I don't remember if it was that. It has to be that. It changed. When I wrote that one, it somehow managed to create this code, LDH, A probably. I will write it the way I write it. Do you see that here? It created this code, LDH, A. IncHL. It did IncHL. It didn't. I will talk to you about. Add a,2. Yes, the compiler managed to do it the way I would initially write it. Maybe it did add a,1. Maybe it did inc a. Maybe it was clever enough. And here it did ldhl, a, IncHL, and you don't care. I swear to God, I do this with 64 lines vertically before I write the assembly, and it goes fast. I'm like, whoa! C code doing software rendering on so many pixels, and it's not like 5 frames per second. It's even 50. It was just on the limit. If you added 65, 66, it will start touching the VBL and then go 25. And I see the code generated, and it did it right. It did it done. Now something changed. We see another case of compilers losing their mind because I changed something in the code. Not even that. I think that's the same. We see that. Is it because I wrote this one? So now, I'm making this video and I want to talk about something else too. And suddenly I'm like looking at my code and wonder what's going on. Now that yeah, no, the same. Now previously, I don't know if it could be, okay, it could be that I saw this nice change with this one, which is the previous version, which I put the CP plus num. Oh, look what I forgot. Could it be that? Could it be that? Here, the first value happens to be, because the sign at this point, it might be 0, but it might be higher. It doesn't matter. It doesn't matter. It happens to be that. And I notice, forget about YP. 70 from 15 is 2. It's plus 2. 17 to 19 is plus 2. Then 19 to 20. So, to be precise, I didn't uncomment it. But it would be funny though, to be precise, before I start, I do that from whatever YP comes, move it to 15 and then go with the differences. Okay. So debug. It doesn't make any difference. It might, let's see, it might move the plasma. Maybe, okay, it's moving, so you don't know. It didn't matter, but I did it. I would be surprised if this thing changes the code generation, changes the optimizer because YP comes first. So that's another example of how much did I build it? I think I built it. How much you can trust the compiler. Or compilers are good, but there is something that, no, it's still the same. But something else changed. I'm gonna find it now. I commented this out. Now I added new code. YP. I hope I'm not writing this. Oh, did I? Oh, could it be that this? No, it's not that. It was commented out. Come on, it would be rendering more. I see this warnings are different. I don't know what. I'm running different parts and right now nothing. Yeah, those comments they're not wrong. They're fine. Now you know. I should move to other things normally, but you know this just took my. Why would you do that? Why would you do this thing with the J-X? Ink E. This is like add 2. And then ink E once. And at some point, it has this spill pair reg HL, spill pair reg HL all the time. Okay, I'm going to do something. You know, the purpose, I wanted to be fast with the sum. Yeah, I'm doing something stupid because I want to. We made changes here. And nothing. No, what? Wrong. Revert. Whoa, 64 plasma and 1 VBL in C. Ah, here I have functions, I comment them out. Oh, did I forget? Can I be such an idiot? But then you see the code here. It's not that. Okay, hold on. I want to see that it's not that. Am I having some printf running because last time but that's only on the init. If dev project sum, yeah, I have it comment. These were all my functions where I compare the difference from sign to the previous and generate depending. I could have here with assembly I could have generated some binary code that I will call instead of having all this I could generate it on memory and that would be better. I should have done it like this. I just wanted something fast there and it was easier to just put the code than search for the hex binaries of this. Wow. So I added this. This was const. No, it's not const. This is commented out. I'm not. I want to be sure I didn't accidentally. Everything is commented. This old unrolled thing, and it's just that. With these are 64. This is the number. Well, plus y not equals 0. It is a unsigned chart, but I check for 0. I don't check. Yeah, for less. It's no going the other way. The rendering would be wrong. And I have the same. I'll be damned. And I think she can do it. Yeah, I was having. This is commented out. Yeah, I was having that version. That could maybe it did 25 frames, or I don't know how much. And then I wrote it with those increases. I guess you're see me doing that crap in another. I don't want to destroy that project. This annoyed me now, and I'm gonna check the SDCC version. Was I testing this with SDCC previous version, and then something changed and the generation changed? Can you believe it? So that's that version again. There is no assembly version yet, but I have unrolled that and I keep the value and increase or not increase. The debug version. Even the colors are different in this version. I haven't used the proper palette. And I am here now. Again, everything is automated with some. It generates a DSK. It took me time to do it. I will be damned. And look, do you see the red one? Your mother's something. The red one is nice. Oh! No way, man. No way. First of all, okay, I think I see. But first of all, yeah, what is the... I put 32 lines. The red one is simply... CPU bar. After the sync, I change the color, and when I finish rendering the frame, so I know how. And you see, it was on the limit. No, I'm here. So if you put 66 lines. Start flicker. It goes less than 1 VBL. It's just on the limit. But even with 25 frames, it's not bad. You could do a big plasma in C at 12 frame rate, and people will be like, "Oh, great! Assembly, eh? Assembly? If you knew." I'll be damned. I'll be damned. This is this version now. C code. Almost doing exactly what we did. Draw plasma. Render FX plasma. This is, look, the unroll. This is the main unroll. It doesn't use HLD. It doesn't matter. It's the same. LDDA, A, IncD, Inc A sometimes. Sometimes add A, 2 if it needs to. It knows to, if it's add A, 1, it doesn't Inc A. And IncD. And here when it comes and there is no increase, you are in the top and bottom of the sine curve and the difference is 0. LDDA, INCD, LDD. Look at this! This is generated by C code. This is generated by this. With an outer loop and the inner loop and all these extra ideas starting from this one or even before and realizing, oh, the value is increasing. I can just try it and increase it. And it managed, at the time it managed to generate code that if I would see this code, I would be like, this is an unroll code of a demo sinner. A crazy demo sinner made an unroll code to precisely get the speed. This is not compiled code. This is not. It happens for simple code. But what's the difference between this and the other one? This is the other one. Again, I have the original. That's the good thing to have the original repo in this one. And also I didn't realize and I changed it. I changed it because, oh my god, why did I change it? Oh, I'm in the same. Oh god. This is the new one. I changed the loop to a do while from a for. I changed the loop thinking even, oh, that's even better. It's gonna be faster because do while, you know. But it doesn't matter. Where's the other? Ah, that's the main. This is the new one. Ah, no, it's not the main. Where the fuck are you? Oh god. Now I have two stuff. There are two FX plasma. That's the new one that suddenly decided this beauty to make this with, I don't know what this spill register, with IX, which is much slower, IX plus index. This is much slower. Oh, and why is it? This is writing. What is it doing? Wait, the regular code is LDHL, E, INCHL. It's still doing that stuff. And sometimes INC and sometimes twice INC. It didn't do add this time because the increments are usually 1 or 2. The sine curve is so small. Okay, it kinda does, but it's using HL and E. And now this one used D and A, which is good because you can do add A, comma something. Oh boy. And it does this. Why is this a bug? Spill register, spill pay reg HL, spill reg pay. Oh my god. Why did you? This is garbage. LDIX plus 4, it's writing L on 4 and H on 5. So it's storing LH. Why are you storing LH? It's storing LH. Okay, it uses HL, LDHL, comma A and increase HL, but it's storing constantly L and H on iota X, on IX. But why? It's not like it's reading it. It's not reading it back. And in case this spill, it's not. We use HL to write E. And it's doing. What the it didn't even need to do that. And suddenly, do you know how many knob cycles on CPC is 4 cycles? Everywhere it's 4. But CPC roundups other, like CPC is 12. So I'm just writing what I'm saying. I'm gonna This one, LDHL, B, or LDD, A, it's 2 knob cycles. It's easier to classify. This is 2 knob cycles. If I did inc L, which is what I do, would be 1 cycle, but okay. 2 knob cycles is the lower part. Deck B is 1 knob cycle. Okay. This, which it's really saying like this, the writing is different here. I think it's 5 knob cycles. Motherfucker. So every step it wastes 10 knob cycles, or this is like 20 cycles. It's storing it, maybe, but it's also increased, maybe to restore it later, but it's storing while I'm increasing it to move. And it's storing it, and it doesn't get it back. Why is it storing it? LDE, yeah, IX. Here it's restoring it, but it's storing it in every step. And you might say, yeah, you unroll the code and you confuse the compiler. It's not only that. But if I didn't unroll the code, I would get nothing. It would be much worse. My god, it's like... Now, there are other cycles taken, but generally I have 64 by 64, and things like that could take at least 2 knob cycles, 4. It could be 5, but if you, in those parts it's 4 or 5, depending. And okay, and I have places where I do this instead of inc A, which takes 2 knob cycles instead of 1. So it's 4, 5, 6. Okay, maybe even 5. Okay. Now I know that Sam Coupe on CPC there are 19,968 knob cycles per at 50 frames per second per frame per VBL. On Sam Coupe it might be, normally it would be 30,000, but there is some, maybe it's around 24. And that goes well. 4,000 is about 5. If it goes even 6, it's between 5 and 6. I don't know the exact number. There is some video RAM bottleneck. But now you have 4 or 5 plus 10. Plus 5 and 5, 10 knob cycles. So instead of 5, you have plus 10, 15. And if I'm close to, yeah, it goes to 1/3. It goes to 3 VBLs. You know, that maybe 24,000. Yeah, it goes to over 2 VBL suddenly from 1 VBL because of that bullshit. So, okay. You wouldn't expect, yeah, you would. I mean, see, that's the thing. It's volatile. Where is my... It might be because I don't even use that X here. It could be here in the comment. So this one is that one. No, I have to go to this one. Put that here. Close that one. This is Sam Coupe. This is the copy. Close it. No. You have seen now. No, I don't want you. Delete this copy. Yeah, I can keep that one. What have I done here? And I was gonna finish now with the video, and I have more stuff, but I went into something unexpected. And that also seems like a bug to be doing this spill register all the time. So here we have build. And you have the slow version. And the thing is, I would have done this in C and think, oh, okay, this is great for C. For pure C, it's great. And I could have started writing with a do while and not realizing. And if I look at the compiler generation, maybe I wouldn't have that. I wouldn't have think of the spill reg. And I think that's everywhere. Everywhere. Oh my god, now I have some idea. But I would have thought, okay, it's compiler code, who knows, and have skipped it. Because I wouldn't know better. I wouldn't know that there is better, but it's only that I started writing this with a for loop. It's only then when I realize, am I running the regular? Same thing, the crazy unroll, but this for loop instead of the do while. Maybe the do while would put this on a, yeah, you know, register will change it, would have to do, but it's so unpredictable. You cannot rely. I mean, you can use, I use compilers, but I would never. Oh, whoa, see? It's still slow. I see on the previous code, I did this for some reason. Oh, why am I putting this value? Oh, because of the do. Is it that? So maybe it's not. Imagine if I can still not get it. This means I had a state that was much better and something broke for whatever reason. I have seen that in the previews. I put this later inside. I say I don't need it there. I had that. I had that. I had that outside, but then I'm like, since I unrolled, I don't need it. Put it here. So this changes the compiler generation probably. Which is even more crazy. You might say, yeah, if there is a do while and not a for loop, maybe it drastically changes some stuff. What in the fucking fuck? What in the fucking fuck? But you have, okay. That wasn't the goal. The goal was to show you something 5 minutes, but that's fine because we are looking something more interesting. That has to do with optimosophy. And I had other plans. Maybe I can mention the plans at the end. I can... Okay, so I'm doing this thing again. What? Oh, no, what? What are you talking about? Ah, because now I... No! But those are here. Let's do that. Bloody compilers. Why? This is a new one. Ah, because okay. I made a copy. Okay, I have to make a checkout obviously. Okay, just revert that. This is stupid. I just made the copy. I just have to see. I don't remember the repo, and I'm just working like that, you know. And now I'm going to revert this second version. So you are gonna see madness, okay? This was supposed to be news, but imagine that it's and I think it's a valuable lesson again, once again. Now I'm going to make a comparison to see. Oh, oh boy! I think that's it. Is it that? No way, man. There was a reason I did that for assembly. I don't know if you can. Is it that? Why would it write back H alpha and not the? Is it that because I used to have a static array and I changed it into a pointer, and that was much later because I needed that for the assembly version. I haven't even shown you. Oh my! But to me that's showing like, and it's not like it still has this. No. You sing it here. I'm getting the video RAM from here. I'm sending it. There was a reason. It could be that. This is commented out. I'm not using. That could be also. That is interesting. I want to see what single line. What single line broke this so easily? It could be that I used to have a static array, and now I have. It could be this one that I'm not passing the RAM, and I'm getting it internally. So I'm doing. I'm doing it even before. I'm gonna have to. I did it for RAM because I was switching between the two and I wanted to have something equal, maybe. I don't know. Oh. Okay. Make a good one. So the difference is I'm not passing the drum. That's the other difference. Maybe the do while goes okay, I don't know. We can see that too. I'm getting it from here instead of passing it outside. Yeah, because here, since these are different and they are common, I didn't want to duplicate code outside. Oh my fucking god! This is it. It wasn't the signs, this is it. This is it. And if you put 66, it's right after 1 VBL. It goes half there, 25. It's exactly. And now the code is. It is this. It is exactly this. Spill. And this one is everywhere. Does it make sense? LDH, 0. The spill is before. LDL writes L and only writes L on IX plus 5. Because it sets H to 0. Add HL, HL. Okay, this is okay. Multiply 16 bits by, I don't know, 128 or something. Plus something else here. Or maybe it adds something else. So it IX plus 5 L. It doesn't even read L. Why? So it writes that for some reason to read it back. No, it reads L from IX plus 5. And what is the spill pair? My fucking god. That could be okay for all I know. Who knows how many garbages? But this one, this is the only way. This one that is the brute force unroll code. I wouldn't have known it if it wasn't for that. It wasn't even the do while. It was that something changes in the generator. Okay, you could say maybe you pass video RAM because it's not local. You can make all kind of assumptions, but you don't know. You cannot predict. Does it do while work? Or does it break it also? Yeah, okay. It saved me from something. This does work. And the code generation is similar. It still uses D. It could have used it. It could have used anything. Or maybe it needs the. You see, even outside, it does the spill. I mean, this is on the outside. This is on the while loop. That counts too. That counts too. It counts less, but maybe you can make 66, 67, 68 lines. So it reads, it says pale reg, but it reads HL. And what did it do previously? It would write it back. It reads it from L and H is 0. To do an add HL, BC. At here, it was a waste because it didn't seem to be doing something later. Oh my god. Oh my god. This took me so long and I wanted to say more. I wanted to say, okay, when I finish, okay, I have to stop now and say, you know what, fuck this, okay. The thing is, why this changed? Because I didn't need that. I need that only for the debug. See, so I never noticed that a simple change broke the optimization to something three-sided. This is why you cannot, you know, when people post, hey, look, yesterday, that's still my old code. Yesterday I wrote this code and there was some really insane, clever optimization. So now I can trust compilers with blind eyes. Because it did something brilliant. It's going to be, no matter what, it's going to do brilliant stuff. No, because if you see now something brilliant and change something, even something that doesn't make sense, that even, okay, I'll also pass another variable or change the order. Maybe I want to pass this here. Even minimal things like that, suddenly this, your clever compiler optimization that breaks everything out of the order will fail. So what I want to say is, okay, I'm not saying, I'm fine. I use compiler for 8-bit. Why am not writing everything in assembly in 8-bit? People would laugh at you, like, you're gonna do things in C, in 8-bit. Yeah, if you do something for 32-bit computers, even early 32 bits, okay, you could go with C and optimize things with assembly. Even 16 bits maybe, Amiga or Atari ST. Fine. Definitely 3DO, for example. But if there is a tight thing that, especially if you know it could be optimized, and you might, if you can work, if you have the motivation, okay. But even in modern PCs, okay, what do I want to say? Practically, yeah, go with compilers to save your time, but don't believe. I have a great disbelief in this blind faith that compiler, this, look, we are living in the future and we never have to touch, to go deep into the code again because compilers are so smart and the AI is so smart that it's over. No, because it's not even whether they do the optimization. It's that sometimes in rare cases you see, oh, finally, it did some really good thing here. And then the next day you change a tiny thing. Oh, why is it suddenly 3 times slower? Although usually that doesn't happen on PC, for example. You are not gonna change something that is being 3 times slower. This is a special rare case, I haven't seen that. But I would not have faith in the automated generation of compiler like it's doing the best job. Because sometimes it changes its mind, it's doing much worse job. So how can you, so it's not reliable. So I will use compiler, but philosophically speaking, any hype virtue signal, it's like, oh, we are living in the future and the ChatGPT or the compiler or all these tools are so magical, we so love it. Any blind faith to the tools being more clever than humans and always doing the best job and so on, it's not. It's not, because it's not even reliable. Anyway, and when I reach the maximum state, I'm gonna finish this. I reach the maximum state where I finally have this that is very close to how you would write some crazy unroll code in the similar idea. I noticed two things. First of all, easier. I don't think the compiler can make sense of this, because this is increment in 16-bit, but you can do inc e 2 knobs, 1 knobs, 1 knob cycle. You can do this is the pointer that points in the video RAM. Or no, yes. Even the sign, I did something even with the sign, but it's the video RAM. Yeah, because because the video RAM of the, I don't remember where it starts. Does it start from, I think it starts from 8000, but maybe it starts from C. But it starts from 8000. You are 0 to 128 bytes per line. I don't care about this linear congruential. Second line is, so okay, it's like 0 to 0.8 to 0.7, and then it goes 0. Yeah. So if your inner loop is inside a scan line, and it's not even from left to right, it's in the middle of the screen somewhere, it's a smaller effect. But even if it goes from full left to full left, it's always gonna change that. So you start from here, and you can do inc L to move to the next byte by only increasing the lower, which is faster than inc HL. Now when you go to the end, I subtract. I'm even here directly, minus 64 plus 256. But this is on assembly, I'm subtracting 64, and then I do an inc H, which is the simplest you can do, because it's half the cycles of inc HL, at least on a CPC. Maybe on a Z80 that is not rounding the cycle. Maybe it's 6 cycles instead of 4. I don't know. Okay. And since I know that my video RAM, I don't know how I can tell the compiler that this is 256 bytes aligned. I don't know if you can do that. I don't know if you can tell the compiler. That would be a nice feature for a future C language. Also today that's not a problem in today's computers. Maybe a future Z80. I don't know if you can do it. You can say, compiler, you can safely do inc E here. 256 bytes aligned. And the thing, okay, it's not 256 byte aligned, because later I continue, I do my minus plus, and then I continue. So it's a 16. In this case, it's not. Because the video RAM is, first of all, it's a pointer. It doesn't know where to. But here is the other thing. This one is 256 bytes, and then I use this one to generate those ones. I do sign2 from sign0. From 0 to 256, intentionally I have chosen this address, which is, I think, is it this one? Which is, again, if you know that you have 256 values, and it's you know that it's 256 byte align. So again, I don't know what the compiler, I don't know how you can tell the compiler, hey, this is safe. So here is one thing the compiler doesn't do. And it's the easiest thing that maybe it could do. You could have some ways to tell it. For Z80 assembly, of course, only. Because I guess in modern PC it doesn't matter. But similar things, there are things like that. There are things like that it doesn't know. The other thing that it doesn't know, but that's this is how I improved it. The other thing that it doesn't know where is it? Because in my version I'm doing something completely different. Here it will do add a, 2. This is 2 NOP cycles. Sometimes if it's 1, it does inc a or dec a later when the sign drops. Dec a, and it does an add with a negative value fe, which is like -2. It's like a sub. It could be sub, it could be a, and it does decay, and at some places it doesn't need to decrease like here. Just write stuff. And that's normal. That's the best it could do, because it cannot think, First of all, I don't know if it has, the way it did things here, I don't know if it has 3 registers. So that in internal loop can do a trick. And this is the trick. At this point, okay, I used it before, but now it's free. I set the value to, so, and I make add a, e, sub e, that's sub a, e, but the assembler here has you have to write add a, e, else it's wrong, but you don't have to write sub e, I don't know why. So this is equivalent to a plus equals 2. And here it's an a, and the sub b, so I'm keeping in a register the value 2. Okay. So these are the 2 extra optimizations that gave me a bit more edge compared to the good compiler version when the compiler is not drunk. Okay. Because add a, register 1 NOP cycle, add a, value 2 NOP cycles. Those are CPC stuff. Cycles might differ. Sam Coupe, but it still works for add a, value. Okay. Also ingel instead of incagel. And I do, in other places, I do such tricks. I realize that the generated stuff I do that, whoa, if I have one more register, everything is registered. IX, okay, I use IX. This is a macro, yeah, I didn't want to write that all the time. Of course, this, yeah. This is a standard macro for the functions to interface push ix, ldix, 0, add ix, sp the stack pointer, and then pop ix. So I have that too. Whenever I want to write something, it's gonna be the same, and I call it get args. If there are no arguments, you don't need to do it. And you even see it here for all my system functions. This ix this is how it works. You get stuff on the stack and you load lh. That's the video RAM address, and I load on B. I load it on B directly because the B is the time, the elapsed time, so that I animate my play. Somewhere here, that's the only place where I could have said add a comma ix plus x, but this is gonna, even if it's in the outer loop, this is once per line. It would take I don't know, 5 loop cycles instead of 1. So I can be pedantic like that. If there is a register I can use there, I'm gonna use it. But then I have to do this every line. This is 2 knob cycles to set the value. So this is 1 instead of 5. So okay, it's more of a gain, because I could have said do that here so that you can put that outside and you don't have to reset. Also we use it to temporarily construct some other address to get this is the vertical. This is the thing that happens once per line, the sign based on the y coordinate. You know, so this is also minimal, but it doesn't matter because the bulk is this. What happens per pixel per line and not per line, but it's good. But even here, it's the simplest instruction: 1 knob cycle, 1, 1, 2 knob cycle, 1, 2 knob cycles, and so on. There are no ix. When I write these title loops, ix are to get the stacks outside, which you have to do either way. There are no ix. You don't open compilers generate because they don't have register and they are automated machines. Generate many times code that in some inner loop. Maybe it's not so important here. They work with ix all the time for many times. That's a lot of cycles. Okay. So those extra 2 tricks, and when I did those extra 2 tricks, now I'm going to put the assembly version. This is 64. Please also enable my CPU bar. Oh, CPU bar is enabled. Which version am I running? How is CPU bar enabled? I thought. Huh. No, which? Oh. Huh? You know what, close analysis. Close the damn thing. Where are we? Are we in the copy? Are we in the copy? CPU bar is 1. You must be kidding me now. Clean. That's so frustrating. Where the hell is CPU bar? It's not that fast. What the fucking hell? That can be. Now I put it 0. I must have broke it. Must have absolutely broke it. I'm not changing the palette every frame or something. Let's put something silly like that. Oh my. I might know. What is CPU bar? Oh my. Border color 15. Oh yeah, I know. Please. Where am I? Sorry guys. Yeah. Oh whoa. If CPU bar 15. No. Why? What was that? 7 RGBL. Ah? Why would you want to do that here? Did I add? Okay, I think it's 16, but that's not how. That's not how it works. Border color 15. Where is the 15? That's the color. 250. Ah? This is getting longer now. Okay, forget about that. Forget about that. If it doesn't work, have I kept the copy? I still have kept it. Okay. What's going on now? What changes did I do? At some point I changed the palette. I know that. For the palette for the plasma. Okay. Oh god. You know, can you? This shouldn't be so long. I not only, you know, I start making a video. I mean, that's fine. That's fine. Think that this is not OptiNews. This is some OptiCode. I was prepared to say, hey, look, guys, I did that in 10 minutes, and now I'm just. Not only it took me more, but I stumbled on my own things not working, things that worked yesterday. I mean, the thing of how the compiler broke is interesting. It is a thing, but this one I might even leave it. Okay, let's see if we change something. That's just that. What? Render FX VRAMs. What? I don't know what I was doing there. It's irrelevant. Better plasma palette. This is where I broke it. But okay, that happens once. I must have forgotten how the border pal works. And I'll tell you why. Because it doesn't... Maybe on some coupe it's something different. Because this happens in the initialization. It doesn't happen every time. Oh. No, it's F8 is 248. Why did I change that? But that doesn't matter. It's the same. And the palette wouldn't work. This could be like I prefer a hex. There is nothing. There is a little detail I don't understand. Because the palette, you can change the palette all the time. It doesn't matter. Why do I do that? This is in the initialization of the whole program. And I set the 15 to red. Why? This is, you call CPU bar, CPU end, before and after, to change the raster, and that's where you change. So why do I need in the initialization to also set it? That doesn't make any sense. And also, because I set the same colors, I'm pretty certain that if I don't set the palette, I will see the CPU bar for some reason. That shouldn't make any sense, because you don't set something that you have to use. You say now the palette for 15 is that, now is that. The CPU bar and CPU end, change them in real time. It doesn't matter if you set it before. And why do I have to set it? See, it works. Why? There must be some detail. Okay, I0 to 8 to 7. First of all, I think that should be 16. No, 15. 15 minus 0 is 15. Oh, it's not... Yeah. Why am I doing what I'm doing? Because I want my palette to go 1, 2, 3, 4, 5, 6, 7, and then 7, 6, 5. To loop back, so that the last color... I see. There must be something about some coupe that I forget. Like, okay. If I not equals 7, let's not set 15. Okay, do I call this all the time? No. It would be very slow. Because I'm generating stuff. There's no way. Okay, there must be something special with the Sam Coupe hardware for the border color. Huh. So that is not going to set 0. 0 to 7. That is going to set half of them. Oh, there were some original colors. This is better actually. The colors are... I have some original colors mixed with the new ones. My god, set single color. And I do this here. This is Vram init. are you running constantly even after? The only thing that could happen that the palette continues to change and I cannot. How about you? But I'm running it on debug. How about you? Are you running? It's never running again. There is no way that I would call by a mistake the initialization. Because yeah, if the color was changed constantly, then much later when I call the CPU bar start and end, and that's only on release. But I'm doing this with some assembly here, 254. And I do set single pal color. Okay, I vaguely remember something. Set single pal color. Set. Where the hell is it? I'm calling. I have one single. Okay, there is a reason why if I use set CPU bar, I set the 15 once to some specific value. It could be a switch in the hardware for all I know. That you have to do once so that, and which we invalidate here. And I put 1. This is the luminosity. Oh my god, is the luminosity something. Okay, let's do, let's see. Or let's put this 1. That's going to be, yeah, that's an interesting detail. This, okay, this is not, but this has to do something. Normally in but see, everything is bright, the background is brighter, but the CPU bar still doesn't work. Okay. This thing that I do only if the CPU bar. I don't understand this. After you set the regular palette, do it. I mean, I can't believe it. It became so long. I'm not gonna call it OptiNews. I'm gonna say, okay, Sam Coupe something. OptiCode. OptiCode troubles. It's like you're trying to do a presentation. Now, if it was a real presentation somewhere, I wouldn't be like, wait, it's not gonna be 10 minutes. It's gonna be 2 hours because I'm gonna have find the bugs. If it was an actual presentation where you give a speech, you wouldn't be like, you would be awkward, like, oh, what the hell, that worked yesterday. But wait, guys, okay, I'm gonna show you something else and speak about it and forget about it. But I'm here like, oh, now this is gonna to be a completely different thing of video. This is me actually in real time trying to figure out. I need to see 254. That's the color, 32 plus 7, plus 7, plus 7. What is 32 plus 7? And then it's a 0, CPU bar stop. And I think that would be border color 15. Okay, the reason that before I do everything, if there is CPU bar, I change the color palette to some value. Could be. Did it work here? Did I try that? The reason for that is that for some reason, if you didn't do it, then much later, and again, if you try to on the fly to change the palette, something happened. I vaguely remember it, and I guess the first time I got it, I also was looking for an hour, and there was some hardware explanation. Now you do out 254, but when you set the palette, you do out on 248, and this this must be for the border color 15. Oh, I know. I think I know. I know. Guys, when you said, I guess with 230, when you said the palette, you might put some RGBA thing. Okay. You might say, how do you set the index? My God, what a detail. I see it now, I see it. It doesn't work the same way that you would expect. Yeah, BA, IX plus 4, index, value index. I guess the index is B in the out C, A can be where BC is pointing, with B the index and A the value and C the, it could be like, but anyway, what you are passing here, there is nothing wrong with that. This is still not going to work. It's not that you have to. Yeah, actually this will work. Okay, I can. But let's make it work in another way. Or maybe not. I wasn't supposed to. Okay, so you have the regular logic where, okay, change palette, index color 5 equals RGBA 2 bits per pixel value. And that could be on 248 out, and then you are 250. So that it's the border color. But now I realize it works like the other. On CPC, it would still be some address. Change border color to RGBA value, not RGB on CPC, but random bytes. Anyway, some other values that is on Sam Coupe, change border color to palette to color index from the palette. This is it. This is it. That's why I initially, and that's weird because I initially set the color 15 to that so that I later use it. But if you change the palette and I happen to flip the colors so that the colors go 0, 1, 2, 3, 4, whatever, and then they go down to 0, and then I choose this and this for CPU bar start, CPU bar end. Do you get it? And I'm like 2 hours, like, why doesn't the CPU bar suddenly? I mean, this needs comment, this needs a different way. This needs, after you change your palette, if you use CPU bar, this will be forced to be. I mean, you could say, you know what, I don't know if it's in assembly. I can't believe how fucked up, because it worked like that. The palette is for that index, here is your color. The border is for the borders. You don't change the palette of a border, it doesn't have an extra. Here is the index of the color that you will use. Oh my god. Can I do this after? So you would do your assembly, hopefully you can mix, and even if you change, but this is stupid because I do it every single palette. But let's try it. Even if you change the palette, please change the color 15 to something. You are gonna break one color from the effect, but we just wanna test. Oh no, it just fucked it up. Else I have to remember or design the thing in a different way. The best I can do is to remember. Even better is to have some kind of engine where later the CPU bar star, I have to remember what this value is. This might be something binary, 32 plus 7. 32. 0111. Okay, this is. Oh, whoa, what? 3, 1. Okay, it's 254, 254, 254. Where are you? Where is it? Where is it? Look how cool Sam is. There are some low ports, low hardware ports. Very few. And there's no, palette. Line IRQ to synchronize with the line. Memory page selection, low, high. Some bits in this one will change. There are bits do various things. They switch the ROM. This is to flip 32K pages from the 512 kilobyte. Okay, there's an exception that those bits in mode 3, if you have this crazy resolution that nobody uses, you use it for the extra color. Four color palette, I think, or something. This is to switch the video RAM page, different video RAM pages. And here is where you select the screen modes, some MIDI shades, a right border here, 025, border color. Yeah, so it's not anymore RGB. Here it's, you set that and you put the byte 0 and byte 1 and the brightness. But here the border color is an exception. You are pointing to an index from the already defined palette. So it's not the same. MIDI sheet, disable screen mode. That is a bit interesting for various reasons. But now it's weird. But bit 02 and there's bit 5. So that's what I did. 1 0 1. Okay, 3 4 bytes. 4 bits. So when I put damn it, 32 plus 7. It's those 3 bits and that. These are the ones. So if you put them together, you would get 15. So I selected index 15. So if I don't select the 32, I'm gonna select now the border color in the middle, which happens the way I generate the plasma. It's gonna be a bright color, and the color 0 here I exclusive array to 0A. It's gonna be the dark, the black. Did I build it? And there you have it. It just happens to be this yellow. Oh my god. But you can't always do that, because what if I generate another palette where the middle color, that's a 7, so it is the color 7 also. What if beware its index if your effect changed CPU bars. I can so that this is the same. Yeah, okay. I don't like that. Oh my god. This could be better because usually if you make some loop palettes, it will be more rare that 7 and 0. The color in the middle and the color in the beginning. Now, I could have some system, some in it that whenever you do that, it will check, read the palette and say, is this the same? Get another color. Maybe even do it once or I don't know. But it's too much. Oh my god. Do you see now? I wasted so much time. Okay, this is gonna be, it was going to be OptiNews. It's going to be OptiCode Sam Coupe. Sam Coupe Troubles. Sam Coupe. I named this project Sam Coupe. But that's misleading because despite this thing, Sam Coupe is, wasn't I pulling my hair with Amstrad CPC and other? Sam Coupe is, it's much nicer and simpler for a Z80 machine also to go. Usually coders hate the 32K bank switching, but I'm okay with it. Oh yeah, right border, read keyboard. I'm under the impression that this is all that you need to control the hardware. Okay, there is something about the sound. Okay, you also have the sound. There must be some other addresses for the sound. 252, 54, 49. To 49. Ah, yeah. I don't think this is some MIDI port, but the sound. I don't see 253. But it's that. If there are more, there are few more. It's so simple. So simple and basic. It would be even easier to write an emulator for this machine than CPC. I think the ZX Spectrum would be the easiest. But anyway. My god, and now we can go back after we realized. Yeah, if you haven't changed the palette, you have to do that. But now that's, I think it might happen that the last color is 0. I think I don't need that. Suppose I'm doing that thing. I don't even need to do that anymore. Okay, suppose I don't set the palette. We are not even doing, but okay. 7 will be that. I guess it's the default palette, or have I changed the palette? Maybe I start with some default palette. I'm not sure. Suppose I don't do it, and this goes 32 plus 7. So it's going to select the 15, and I haven't set a default 15. No, it will still get a white. Maybe I wanted to make it red. Nah. And it doesn't matter if it's red, it is green. You just want to see the difference. Okay, this could be improved. We could go back because we took a lot of different directions. You have seen, since I started before, you have seen that this C code is barely at 64. Maybe it can go 65. This bar was like here. With the assembly version gained a bit, which is cool. Which means because of the extra, the assembly version, I think I reached 90 or 92. You can make 64 by 90. Yeah, see, barely. Maybe 92 breaks it. Yeah. 90. Ugh. What? Maybe 91. But 90 is fine. And you have an amazing plasma, 64 by 90. Pretty big. I could do that full screen. 64 by 90. Now, since we render half scan lines vertically, the screen is 256 by 192, and I divide by 2 since we render half scan lines. Okay, divide that by 64, divide that by 90. I'm in the programmer. 5760. Divide by 5760. You get, okay, if I did this full screen, but half scan line, not all, I would, okay, but it would be a full screen plasma, which would be impressive. I would be over 4 VBL. Yeah, and I would like to be a bit under, because with VSync I will be at 5, so I will be 10 frames per second. Okay, then I will be so still to make it. If you make it full screen, let alone if you wanted to fill every scan line, it would be divided by 560. You could take it, it will still be slow. If you, even if it seems big and you see there is not much area. Oh no, wait, I must be missing something. Oh no, it's a bit better. It's 64 bytes. 64 bytes, not 64 pixels. And that's why you see the patterns horizontal, because I'm lazily getting the byte and just writing it. But it works better than it would work on the CPC. It's not 256, it's 128 bytes. Divide by 2, because we write half scan lines. Divide by that. Okay, you could be just over for a full screen with half scan line, just over 2 VBLs. I would wish we were under. So if you cut few lines, you can have this full screen. I'm gonna do it later. A crazy full screen plasma at 25 frames per second. Wow. And obviously, if you do it full scan lines, 128 by 190. You get it at 4 point. You will go there to 510 FPS, 5 BBL. If you get it at yeah, you can get 12.54 VBL. You can cut the full line. You can say okay, 128 by I don't know. 188 or something. Anyway, it doesn't matter. You can go 160 or something. Yeah. And you can easily be, or... Wow. But if you were to properly do every pixel, it's gonna be way more slow. So it is a bit of a cheat. But look, I'm like, I prefer the 64 version. And let's, I got, this was even on. I forgot it on. I see I'm doing double buffering. If I disable the double buffering, is there vsync? Is there still vsync? Ah, you see the tearing. No vsync. There must be still vsync. Yeah, so if you remove the vsync, it's running faster. How did I run this? Yeah, you might not see it. I think it's run. Let's put the, let's put the 32. Yeah, it's going fine. Without vsync, it's going like crazy. Sam Coupe, man. Yeah, put back the double buffer, disable the CPU bar. Oh my god. Sam Coupe writing C. I could make a demo in C. Okay, C and assembly. But this 64 was barely running. While this one, I have, the assembly one, I have space to play music, to have maybe a scroller. It's pretty cool. I could stop here. I was doing stuff here. I was trying. I don't even remember. Okay, I wanted. That's how it started. This project started some sprites, but then because I wanted to. I had some balls, and I wanted. Now I'm rendering them like an idiot. Okay, this is just to display, so that I can see. But my goal was to generate some assembly code, and I got bored and didn't do it. So this is something I left, part of RAMs. I'm just rendering. Ah yeah, I have finished the system. I have rendered. This is not rendering right now. This is generating. Sam Coupe has a lot, because it has 512 kilobytes of RAM. You can have 16 different video RAMs that you can flip with each other. And I generated some different screens. That's why it takes time here. And now I'm just flipping them. Now I'm not using any CPU, and it just I wanted to generate some different pattern, something better, maybe even some 8x8 texture that repeats. But my goal was different, because long time ago, when I did this one, but that's on assembly. What I did is you have those moving positions in video RAM, But now using line IRQ and at every line changing again which of the video ramps to display, I could do some sine wave over a pattern. This is happening on the hardware. I don't do any software rendering at this point. I just per line I switch, and this is much easier on the Sam Coupe. You have the line IRQ weight and then you just change stuff. It's much easier than if you wanted to do this on CPC, you need more CRTC syncing and setup. The plasma, I never started this one. These are placeholders only. So I'm just doing something like that, something stupid. Just rendering. I was going to do some. I never started this one. It's the same, see, placeholder. This is the one. I tried to see if I can do some 3D stars. I have very few 3D stars on Sam Coupe. Now that could be optimized. Even though I already run tab, but just I already generate source div z offset. What am I generating this? Oh, div loot. What is the div loot? Okay, I'm already generating a division table. That is stars cube depth, stars cube length, size. 120. This is like 8 kilobytes. I could do it in 16 kilobytes probably if there is space. So I already tried to do the stars by avoiding. Now these are not many. These are 96. And so, you know, previously I could do plasma for 4096 and here I struggle with 96 because there are more that happens. And when I manage to calculate the positions, this is to write back the source points to the stars. It gets the Z's and it does some offset to make the stars move. But previously I used the Z to divide X and Y. Which X and Y I get from here? X, Y, Z. So I write the Z back and then increase. And I do +1, minus count, and 1. They move either by 1 or 2, depending on the count. 2 speeds. And the thing is, I have to do all this stuff normally. I still have to do work to find, okay, with this coordinate, where exactly which byte I should write, and I have to shift some stuff. Now, this could be optimized with some pre-calculated mapping, something. Because whether on Sam Coupe or CPC, the pixel render can be much faster. Now I did it in pure C. I wanted to write something in pure C. I didn't care at the time. So like, can I do something nice without writing assembly? And you can, but you are going to have 96 stars. So when I build that, it generates the divisions. That's why it takes time. And you have, I don't even see, a 96 is not, is less than 1 VBL now, I'm seeing. It was just a nice number. Maybe 64 is a good. They are very little. I'm wasting it. It's the generated code of the C compiler. Probably it's doing the spill HL thing. Even 64 is not, That surprises me now. Yeah, these are the things. If you want to have 256 stars, okay. And I'm not doing real-time divisions. I'm not doing something crazy. But have you seen the difference? You know, when I wrote that, I thought that's fine, but if I cannot move more than, I don't know, 40, 48 stars at one VBL, how are you gonna suppose to do a plasma effect in pure C? But the pure C, if the code was so simple and the compiler still didn't do stupid things because you changed something, the pure C for 64 by 4, 4096 would be like, oh, you can still do it in 50 frames. But then you come in a different thing, so I'm not doing some crazy math. And only for 48, is it 48 the limit? When I first did that, it was nice. It was like, oh, I can do some little stars with pure C. Not bad. And I thought, yeah, that's normal. Not even 48, 40. And it's not from 4096 to 4100 less. Is the compiler doing 100 times more? Those could be okay. I guess especially the shift by 7 times. You know, the Z8 it doesn't have it has to shift 7 times. It shifts by a number. Oh my god, by non-constant. And that's the pixel shift. Mask value. The offset is the first. So what if I said, yeah, you know what? You know what? Fuck it. Just render some garbage there. It's still barely. It didn't gain much. It creates some weird shadowy. That shift is... It could be more things, you know, reading from arrays. The compiler is going to be so confused when you write something more simple. That could be simple. This is a loop where I erase. I have also kept the stars and erase the previous. These are the things that you have to write in assembly. You could easily do 256 stars at 50 frames, I think. They have a nice shadow. You see another darker color, but that's why... That's funny. Because I don't do it properly, you know. Just get it and write it. Now, how could I... Let's do something wrong and do it. Let's see how much that shift affects, because it's gonna be 7 shifts. Maybe it still doesn't. Yeah, it was there. It didn't. You see, it's all of the thing. Yeah. But if you are like, okay, maybe I will be 3-4 VBL, it's nice to wake up one morning, write some 3D stars and see on this 8-bit and see, oh, it's still nice. Slower but nice. I wrote the same thing on Atari ST Amiga in C, and it was smooth with 256. And there I might have even used a division from the 68,000. I had one more thing. What if you don't erase the stars? Or maybe not. Again, is it 40? Oh, now I want to do experiments. I want to finish with that soon. Okay, that's barely on the VBL. So what? If I don't erase, if I don't call erase stars, if I don't do the erasing. Yeah, okay, the erasing is minimal. It was barely under the VBL, it was flashing a bit and now it's a bit over. Nice. It's mostly this. There's a lot of micro things happening. That would be much more optimal on now that has a nice instruction with shifts for free. But not on the day, especially in the compiler. And I mean, just before we leave, let's look at the generated assembly out of curiosity. Also, oh my god, erase stars. Spill reg, spill reg, spill reg. I hope it's not doing. LDHL0. This is how you erase. I have unrolled, but every unroll part seems crazy. LDHL, 0. ADHL, BC, LDHL, LDL, A. There is some A ink DE, LDL. What the fuck? And people will say the compiler doesn't like, you shouldn't unroll code because the compiler doesn't like. Yeah, but when you don't unroll codes, it also doesn't do. Oh, I guess okay. It has to read this and get the value. Compilers get confused. It's not like a DST +1, +2, +3. That one I could easily write that in some tight assembly. It's a very simple one to write. It's not too complicated. Oh my god. Yeah, I guess it has to read. I don't understand those spill pair reg thing. I don't know if it does more than it should, but and then this one, you see that everywhere. I don't understand. Maybe at some places it's okay. Oh, color is the main loop. The main loop must be here. All of it. Look how many IX. There are too many variables. There are just too many variables. You know, I would never write an inner loop I tries to do. When I would never, in very few cases, on the Z80, there is a file. It's like you have to avoid IX. So I'm doing my best to construct the inner loop in such a way. I would use things that are unoptimal in the outer loop or in the initialization. But I'll give great fights when I want to make something pretty fast. Unless I'm lazy. But even when I'm lazy, I rarely have the need to, in an inner loop, to use so many IX. And what are these? There are IX -6 files. These are looking at the stack. It's the compiler models where you have the stack. you push the stack to IX. This is how, this is, you know, the generic technologies that we have designed to, this is something that all compilers do. This is, I don't know, this, and if you wrote your own compiler, you would probably do that too, but you know, an actual assembly programmer would just try to fit everything in register. There wouldn't be so many IX. This is 5 knob cycles instead of 2, or 20 actual cycles instead of 8 for every read. And also a lot of the variables you could fight to keep them in registers. This is unbelievable. Where is this loop? DGNZ there. Where's the main loop? Oh my god, look how big it is. So I think this is jumping. Pop AHL, push AHL. 136 and 1. My god. Of course this is compiler. Of course this is slow. But what can it? There are so many variables. And compilers, even with simple programs, will make, and will end up saying, okay, I just have to use the stack everywhere. But assembly programmers on the demo scene, on the Amstrad, on the Spectrum, will write all these effects from Plasma and so on, which have fewer variables if you do it right too. You know, the dot effects and other things where there are more variables will fight to write them so that in the inner loop you don't see that. There is no way. And that's how you get from 40 to 256. Like, I don't know, 8 times more. Or dot records with 1000 dots on the CPC or something. You know, the Batman Forever stuff. It's something completely different from the compiler, but then it involves other things. But if you didn't do these extra things, and if you try to write the regular thing by putting your mind of how could I write this optimal for the Z80, not just you don't copy the logic of the compiler with the stack. You don't. You say no, that's not. This is not how we do things here. You know, that's not how we do things here. If you do that, it's day and night. That was a trip. You know, my plan was to make OptiNews. But I ended up doing some OptiCode only on Sam Coupe. And I wanted to talk about 10 minutes about the Sam Coupe and then go. Because what I was doing wasn't what I was doing this day. I bought this Agon console. I bought this version. This has an EZ80, the beefiest, the latest Z80. And this is it's based on Agon Lite. This is pretty interesting, but there are a lot of junky things with it. Like, you don't have direct access to frame buffer, and you have to upload bitmaps that you later bleed. So if you try to make if you wanted a frame buffer to do the effects I'm doing on Sam Coupe, I could show you very little. You wouldn't. Let me change something. Okay, let's. So that's. Oh, where is it? Okay, I'm going to disable that because this fast VDP only works on emulator. On the original machine, it's like 10% faster only. So that you see the actual speed. And I will. Okay, hopefully it's that. So unfortunately, my thought was that this machine has the. Oh, here's the EZ80. This is the last Zilog CPU, and it has 24-bit addressing. It has a mul 8-bit by 8-bit to 16. But the best thing is it's a beefy Z80 with few extras. There are some annoying things that are missing, but there are a few extras. And there are different addressing modes though. Either original Z80 or 24-bit addressing. So there are things to learn. Where is it? And I was noticing that the instructions have much fewer cycles. For example, an add A, register, add A, B, C, and so on. It has one cycle. On the Z80, it had 4 cycles. So at the same megahertz, this one is a lot of stuff are 4 times faster. This is the most amazing. The 16-bit add on Z80. Now on CPC it was 12 cycles, but on ZX Spectrum and other I think it was 11 cycles. You know, CPC is rounding up the cycles by 4, so we lose something. But this one is still 1 cycle unless you go on these modes. So it's like 11 times faster, but usually it's 4 times. Now these modes, there are different modes. If you are not in ADL mode X, like you're not in ADL mode, but there is a 1 and 0. Then it works like a regular Z80. Yes, see the opcode is smaller. Also, that's another thing. And but if you are in the mode where HL now is 24-bit, and there is an upper byte that you can't easily access, then if you do a regular add or you do an add L, then this is 24-bit add, but I think this is 16-bit. It adds there is something I have to see that, I'm not sure, but a lot of things, if you see the cycles and compare how it used to be in the original Z80, it's crazy. It's crazy. And there is a mul, there must be an unsigned mul. So I thought, whoa, if I can do on Sam Coupe on CPC this plasma, imagine what I can do on this machine. But because it's using the VDPGL video processor, it's using the Agon VDP. Some kind of hardware called ESP32. And it interfaces through a slow connection with 100 kilobytes per second. That's not enough if you want to update. And you don't have direct access to frame buffer, and so the sound. Yeah, I need to disable the sounds because it's gonna beep all the time. So I can barely get 24. I think I got 25. So this is what I was working, and I realized there are a lot of, I was disappointed. See, this is the same thing. Although, for good colors, I have to use a pixel map at this point. But the assembly version was lazy. The assembly version. So, you see, I ported that one. So, on Sam Coupe, that is much slower. I get 64 by 64 or 64 by 90 lines at 50 frames. Here at 64 by 64, because of the upload, I get 21. 22. The colors are still weird. Now, if I omit the drawing of the plasma, so we are doing the rendering, we're doing similar. Okay, there is also this picture. That could be a bit slower for the Z80 generated code, but okay. And I think the assembly, yeah, I cannot do that here, that thing I like to do to group the functions so it's more junky. But it's basically very similar. See, you get that from ix plus 6, but it really gets the upper. There is no, it gets a 24-bit because we are in ADL mode. And maybe I should see if I can switch to the Z80 mode, because some things are one cycle less in Z80 mode. For example, this one is 2 cycles, I read, on ADL mode. 1 cycle on Z80. But I think also this. So this one, I think it would be that 24-bit. You don't see U. Somehow you set U and use HL segment if you were in Z80 as it's full. And there are more. There are this I don't know if it's here or here. LDCs. I need to see that. That you can force it to use another method, but anyway, it's interesting. If you do it correctly, it's going to be beefy. But because I have some functions, maybe that's okay. You select the bitmap and you draw. It's this one. It's the upload. It is the upload. That is 100k per second. Maximum. So if you have a 320 by 200, the 100, you might be at 1.5 frames per second. Now the 64 by 64 is 4096, so you are 24, and that's what, if I don't render the plasma, I'm close to 20 frames per second. And this is smaller because the pixels are smaller. I can't even get some blocky pixel. And see, if I disable draw plasma. What do you want now? Ah, yeah. Apparently. Now I'm not uploading the bitmap, but I'm rendering in the background, and I get 165. 165 frames, man. But I quickly realized this is not enough because this platform where are the specs? Does it say? Okay, it's an EZ80. And Agon specs. They never say that. Oh, okay, it's at 18 megahertz something. Yeah, it runs at 18 megahertz. I paid that much for the whole thing. 3D print. Now, is it a Wikipedia? Previously, I bought this one, but I never did anything with this. But I wanted. This one has the same at 48 megahertz. Because my thought was, they made a Game Boy Color emulator. Wow, they made some. I think there was a ray tracer. I'm like, and I wanted to do some because I'm like, imagine Z8 at 48 megahertz, but also 4 times faster than Z8 in the same. It would be like Z8 on the CPC on the Sam Coupe at 200 megahertz. Imagine what you can render. And I got that and I'm like, okay, this is a bit lower, 18 megahertz, but still it would be like 4 times that. A regular Z80 at, roughly speaking, okay, because there might be difference, there might be memory bottlenecks. Okay, so this 164, if I could get for 64 by 64 50 frames, 18 divided by 6 megahertz, but that's roughly, okay, that's not a very scientific way. It should be 12 times faster, so 50 by 12, I should get 600, and I get 1/6 something. Assuming the compiler generates the same thing. So anyway, I also made the assembly version to check that. Oh, do you think, oh my god. And it goes crazy. It doesn't go 600, but it goes 400. So the same plasma from 50 FPS runs to 400. Actually, that's the 64 line. Yeah. It should be even. But anyway, I stopped at that point because it didn't make any sense. Because by the time you render to the back buffer and you upload that back buffer for regular updates, from whatever, you get 20 frames from. So and that's even for a small thing. Imagine if you wanted to, because that was my dream, to write something for the EZ8 and do some crazy big demo scene effects where I'm changing 64,000 pixels and it's still smooth enough. You know, that was my dream. But I realized this machine works in a different way, and you have to send commands, you have to communicate commands slowly to draw lines and triangles, to draw bitmaps. So it would be better to do some 2D game where you upload your bitmap once and you just draw it. And even then there are some issues. Even then it seems that if you were to draw a lot of bitmaps full screen, it's not gonna reach the 30 frames even. And I've seen things that people did. There are some nice things, but it's not as impressive. But you know, I like, it's a new platform. The firmware is updated. Things might be improved. This thing was even slower. It wasn't 20 frames. It was like 5 frames, 7 frames per second with the older. The older firmware had you to upload RGBA 32 bits instead of 8 bits, which is the 64 color mode that is regular. And it did some internal conversion, I don't know. Pretty weird. And I was doing other tests here. This is even slower. A rotozoomer. That's similar like the speed, but that's now the rotozoomer. The compiler, it's just C, by the way. It's pure C. The compiler created much worse code. But even for the plasma, it didn't do. This compiler didn't do. Man, this is. Yeah, I mean personally, this one. Even if you. And I noticed something. Even if you say, yeah, I'm not gonna upload the bitmap, you don't get much better. You get 22 because the C code is not. Even if I try to optimize it, I even noticed something weird. It doesn't do much, the C code. In X and Y, you add the interpolation, but okay, you do it with 16 bits and not 8 bits, which should be okay for additions, but probably the shifts, it's not doing a good work in the end. I was looking a bit at the code generation. Now here's the thing, I unrolled this and this compiler is even worse because first time I unroll it and it's not 20 something, it's 15, it's even slower. How is this possible? Okay, so here is a case where, okay, I have a macro now so that I don't repeat myself. I have my macro somewhere else anyway. So I'm like, how? I might have watched the generation a bit. And there are more issues with this one. Now, in one way, this makes it more challenging and interesting to find alternative ways to render things. I mean, for the plasma, I could upload the scan lines as bitmap and select different scan lines, more like the way it's happening. Here is the code generation. Yeah, it goes in ADL1. Actually, can I do that? I'm gonna try that too. Oh, I see. I was gonna finish that, but okay. Not full unroll. And a plasma symbol. Full unrolled. Full unrolled C. Is that one with a better of course, there is the extra pixel map that could make things a bit worse. But anyway. Okay, maybe here. And you see again a lot of IX and I. This is the unrolled version. It seems a bit more clear. No registerSpill, but there are some extra modes. You can LDIX, AJ. You can write 16-bit mode. I've seen that. This is the new Z80. You can write the 16-bit value on AJ. I don't know if you could do that before. I've seen something else. I've seen something like that, LDBC, AJ, and I don't think you could do this in the original Z80. So there are a few extra stuff. And here IX isn't so bad, but it's worse. It might take 5, 6 or 7 cycles instead of 2, especially IX plus offset. But it's like, okay, it's not 20 cycles, it's 5, 6. Again, roughly 4 times more. But again, if you were to write this, you know, by trying to avoid this thing, it would be much. It puts pop. This is the unroll part. Or is it this one? Huh. That's also interesting. But it's not as optimal. Okay, the rotozoomer. I've noticed it calls iMulu. This is for signed muls and signed shift. Sign end or I something and it calls functions for doing this stuff. Even in the inner, somewhere in the inner loop, there was an end and a shift because in the inner loop I have to shift right now. It doesn't. Maybe it doesn't recognize that. Oh, this is if this is HL, you can just give a age. You can say LDA comma age and done, and do whatever, and then end a comma text with -1 and so on. But then again, it depends on the cache. So it's very, and it is 16-bit and it is a signed integer. So, and I tried to make it unsigned, but there was a issue because this could be negative. But at this point, I just want to get the fixed point value. So if I write this in assembly, it will be definitely much better. I wouldn't write an inner loop where I call functions. Now, some 16-bit values you need to do stuff. I might have tried after the shift to, I don't know, I might have tried to cast it. There's that. I just might have, I don't know. It still seems 22 anyway. Also, if you, I need to disable this. Oh, but that's the wrong. Oh boy. Okay, let's do. Since we made it, then I need to disable that beep. Is it slower? Oh no, it might be because. See, there's that thing. Oh no, I didn't do it here. Yeah, so there is that. Well, maybe if you can cast it, the compiler can. Yeah, you don't know if it's better. These are really things that who knows when. You have to write in assembly because the C compiler code Z8 is not easy to optimize. It's far from. You know, I think I have to migrate in that. It shouldn't be hard. It says that it's easy. Because everywhere I see people. This is also doing Z8. Now it says Z8 underscore Z8. Maybe it's only it's non-ADL. I don't know. which could be okay if you can work. Actually, I wanted to try one more thing, which is I noticed it's gonna break because if you put ADL 0, you know, ink ADL is faster. This could be faster, but it's going to write in the wrong places because you are passing a 24 byte. It's gonna crash. But let's try it. Yeah, and let's try it just for fun. So you have to take care from that. But I know that if you manage to write something in Z80, if you don't, if your data are fitting in 64K segment in a way, yeah, it just fucking crashed. If I figure this out, I could write only. I mean, it is Z80, but the meaning changes. You know, AGL is not 24-bit; it's 16-bit, and the address that you passed now it's not. See, it says IX plus 6, and then it goes 9 because that one, which was that, it was a 24-bit, 3-byte address. Now this is 1 byte here. And also, it says plus 6 because, it's not plus 4 anymore, it's plus, yeah, plus 6. It was plus 4 because you have the stack point, yeah, it was the base of the stack or something. Yeah, and it previously stored the return address. Yeah, plus 6 is 3 and 3. So previously it stored 3 and 3. Yeah, the return address and maybe something else. Yeah, it used to be. See, you see even here that we are in ADL mode, 24-bit addressing, and you have to be careful because you might say somewhere else. I might say LDS, comma. If I do it like this at least, and I might think that AGL now points to this, but it will really point to whatever is in the upper byte. And sometimes it's referring that UHL or HL, U or UHL, something. But you don't have access. You don't have access to that. Now, if you don't write it like this and you write LDHL, as long as you are on ADL mode, I think it's gonna store that. So you can also write FF0 or whatever. There are things like that. And I think there you can do LDCs or list. You can do something, I don't remember, that tells you write 16-bit or something. Load 16-bit, write 16-bit for those, but by default it's all 24 bits and you can forget about it. You can work like that. But this one, if this one takes 3 cycles, the 16-bit will take 2 cycles. So there is a bit of a gain. So my thought is that if I can change ADL to 0 for something and work like in the past, it will be even faster. As long as I can able to get a specific memory segment, and there is a lot. Yeah. I could be talking more about that. I have more stupid tests. But maybe I should close. It is interesting. I like everything is open source. The basic, the operating system, the firmware. That also that's the library that the firmware is based. The docs, everything. It is frustrating, but it has a community. And I'm thinking of ways to overcome things. And there are some interesting functions that you can upload. Instead of just bitmaps, you can upload commands that do other commands. And there will be tedious ways to trick the hardware in some way so that I can do a bigger plasma or something. And still there are issues. Anyway, that was a crazy trip. I guess this will be OptiCode rather than... Because no, that's not OptiNews. And we'll see now, because I don't know. I'm a bit consumed by that, and I haven't been doing much on the 3DO. But soon I have to at least come back to the Bizarro Underground. And I mean, I might have other ideas, but I have to focus on Bizarro Underground so that I can finish and work on other ideas. We'll see. And I don't know, I don't have plan for a finishing date. It would be nice if I can progress and finish something by the summer. Unless something happens. So that this doesn't consume the end of the year and I can work on other things. Maybe I can also look back at OptiDoom. We'll see. Anyways, that's it, and I guess sorry for the huge video, but it's just OptiCode runs, you know. Just the usual stuff. Bye.